accordingly. So just be careful with that. Last page, it says find the inverse of the following and verify your answer. Listen, we did this in IM3. These are just more complex ones because they have more than one x. We did it in IM3, but we did not verify. Now you're responsible for doing the actual inverse and verifying as well, okay? So first off, to find the inverse, basically f of x is just representing a big fat y. I would try to write small if I were you, by the way. So right now I have y is equal to x over 2x minus 1. The first thing about finding the inverse is you switch your x and y. First and foremost, switch your x and y. So y becomes x becomes y, x becomes y. And then you solve for your new y. Solve for new y. Every single time. So basically, since I'm currently dividing by this whole quantity, I'm going to multiply the whole quantity over. So I'm going to have x that I have to distribute to the quantity 2y minus 1 is equal to y. You're going to have to distribute the x, so you get 2xy minus x is equal to y. And hopefully at this point you notice this term has a y, and then I have that y. The whole game plan is you want to get your y's on the same side. So once you get your y's on the same side, you can factor it down to just one y. So since this y is already by itself, I'm going to go ahead and you could do, if you want to get rid of this negative x, technically, you could subtract this y over and then add the x to the other side. I might do that just so that becomes a positive. So I'm going to subtract the y over. So this is gone. Add the x. I'm going to get my y's on the left side. So 2xy minus y is equal to x. Now that my y's are together, I can factor out the y that they have in common. So I'm factoring out that y. I get 2x. Don't forget, if you factor out this y, you need a minus 1 as a placeholder. And then finally, since it's y times the whole quantity, I can just divide the whole quantity over. So I get x divided by 2x minus 1. That should be your inverse. Your inverse should be, which if this was f inverse will be written with this little -1 sign. That's not an exponent or a power. This legit means inverse of f. Inverse is x over 2x minus 1. Now, as for the verification, it should work out both times. And this is when we have to do f of f inverse and prove that I get x, and then f inverse of f and show that I get x. It's a lot of work. You're going to see, because this ended up matching that, which usually does not happen. It does usually not happen. It's just the way the graph shape is. Since these are matchy-matchy, I only have to do one way because the other way will be the exact same. So it kind of will save us some time. So first thing I'm going to do is this setup. Basically, I'm plugging the inverse. So I'm going to plug this guy into the original. So I'm plugging this guy into this original. So since I circled my inverse in blue, I'm going to write this one in blue. So this is where it's going where any x is. So since I have x up top, it's going to be x over 2x minus 1 over 2 times x. So 2 times that whole fraction minus 1. So again, I'm putting this in for that x, done, and that x. I'm going to write it right now. And I have to simplify this and show mathematically how it is equal to x. I would put this 2 over 1. So you know this 2 just goes to the x up top. It only goes to the numerator. But that being said, I'm going to have to get a common denominator. So since this has a 2x minus 1, I'm basically going to just change this 1 into 2x minus 1 over 2x minus 1. So here's this top. He's staying exactly the same. X over 2x minus 1. The bottom, here's my common denominator, 2x minus 1. I have 2 times x. And then you do have to distribute that subtraction sign. So negative times 2x is negative 2x. Negative times a -1 is plus 1. Stuff should cancel, at least one thing. That does, so that's a plus. Now I'm left with x over 2x minus 1 over 1 over 2x minus 1. Now that I finally have one solid fraction divided by one solid fraction, I can multiply by the reciprocal. Anytime you do the reciprocal, you're like, please, please, please let something cancel. The 2x minus 1s do cancel, and it's equal to just x. Check. Technically, that's only half of the check. Then we should do, if this was f of f inverse equals x, now you should do f inverse of f of x and also show that you get x. So now we would start by plugging this down here. But since they match, it's going to be the same. So I'm just going to put they match. So same steps as above. So same steps as above. And then that would be my other check. I'm not going to rewrite it all over again when I get the same thing. The next one does not match, so we'll actually do both. So we probably even have to write smaller. So let's do the next one. If I'm going too fast for you, you can pause and rewind at any point in time, don't forget. So again, f of x is a big fat y. I currently have, how can I give myself more room? Y is equal to x plus 5 over 3x plus 2. First step is to always switch your x and y. So y becomes x becomes y. Now you're going to solve for your new y. Since I'm dividing by this whole quantity, I'm going to multiply the whole quantity over. This might be one where you might even want to actually pause the video and try it on your own and then unpause, see if you did it right. But most of you probably won't do that. You'll just keep watching, which is fine. You'll get practice for homework. It's not a big deal. I multiplied the whole quantity over. I'm going to distribute my x. Now I have 3xy plus 2x is equal to y plus 5. And hopefully you note that I need to get this y and this y on the same side. So whether you choose to go left or right, whatever, it doesn't matter. I'm going to put my y's on the left. So I'm going to subtract this y over. And then I'm going to subtract the 2x over. So I'm going to have 3xy minus y is equal to, I'm going to put the negative 2x first out of habit, negative 2x plus 5. Now that my y's are together, I can factor it down to just one y. So I'm dividing out the y. I get 3x minus 1. And finally, since it's y times, I can divide that whole quantity over. So I get negative 2x plus 5 divided by 3x minus 1. This should be my inverse, negative 2x plus 5 over 3x minus 1. I say it should be because now I'm going to have to verify it. So verify. Just like above, but I'm going to actually have to do both. So we'll try to stay below, we'll try to keep above this line for the first half, and then I'll have room for the second half. So here we go. First check, f of f inverse has to equal x. I'm going to make the inverse blue. So this is going to be blue when I plug it into the original up here. So every x is going to be this entire fraction. So I'm going to have, instead of x plus 5, it's negative 2x plus 5. You can see how this is going to be obnoxious. Over 3x minus 1 plus 5. So I'm going to put plus 5 over 1 because you know I'm going to have to do a common denominator. The bottom is 3x plus 2. So 3x plus 2. I'm going to put the 2 over 1 again. 3x, x is the inverse, so I'm putting it in blue. Hopefully the color coordination, you can see the blue is the x. I'm plugging the inverse in for x. So it's the inverse plus 5, 3 times the inverse plus 2. I'm going to make this 3 over 1, so I know this 3 is only being distributed to my numerator. I'm also going to get common denominators in general. So if this has a 3x minus 1, this needs the 3x minus 1 to the top and to the bottom. If this has the 3x minus 1, same deal. This needs the 3x minus 1 to the top and to the bottom. So we're going to have some crazy stuff. Here we go. Here's my common denominator, 3x minus 1. I have the negative 2x plus 5. And be careful here, you're distributing a positive 5. Positive 5 times 3x is plus 15x. Positive 5 times negative 1 is negative 5. I would simplify that. Let's see, plus 5 minus 5's cancel. I have negative 2x plus 15x, which is a 13x. Trying to leave room because I hope I can flip up in that space. On the bottom, here's my common denominator, 3x minus 1. I have to distribute this 3. 3 times negative 2x is negative 6x. 3 times 5 is positive 15. Also distributing a positive 2. 2 times 3x is 6x. 2 times negative 1 is negative 2. Here's my common denominator. Again, something should cancel. Negative 6x, positive 6x. 15 minus 2 is 13. When I do my reciprocal and I flip it, and you're like, please, please, please let something cancel. So I usually do like the weird squiggle because nothing canceled. It just moved. And check it out. 3x minus 1's cancel. 13's cancel. I'm left with just an x. Check. Halfway there. Halfway there. Now I have to do, so I left enough space. Actually, probably could have gave myself a little bit more room. Now I'm going to do f inverse of f of x and show that that's equal to x. So this time, I'm making the original. I'm going to make this guy up here blue, and I'm putting them down into the inverse. So all of this is going to be in my blue pen, and I am putting this down here wherever there's an x. So this will be in blue for that x and that x. So I'm going to have negative 2 times that big old fraction plus 5 over 3 times that big old fraction minus 1. And you can make it a 1 over 1, really. So again, I am putting this original in here. So it's negative 2 times that fraction. And then again, 3x minus 1. So hopefully with the color coordination, you can see. And I would put this negative 2 over 1, the 3 over 1, so you know the negative 2 just goes to the numerator. All right, common denominator time. This has a 3x plus 2. This does not, so it needs a 3x plus 2 to the top and to the bottom. Same deal here. 3x plus 2, top and to the bottom. I might go below this time because I don't know if I can squeeze it. Here's my orange fraction bar. Here's my new numerator with the common denominator, 3x plus 2. I'm distributing a negative 2. Negative 2 times x is negative 2x. Negative 2 times 5 is negative 10. Be careful here. Watch the sign. I'm distributing a positive 5 times 3x. That's a positive 15x. Positive 5 times 2 is a positive 10. When I simplify that over the 3x plus 2, again, something should cancel or you messed up. Negative 10 plus 10 by. Negative 2x plus 15x is 13x. Bottom, common denominator. Distribute the 3. You get 3x plus 15. Be careful here. I'm distributing a negative 1. Negative 1 times 3x is negative 3x. Negative 1 times 2 is negative 2. Again, something should cancel. Positive 3x, negative 3x, gone. 15 minus 2 is 13 over the common. Now that I have one solid fraction divided by one solid fraction, I can multiply by the reciprocal. Make sure you actually flip it. And anytime you multiply by the reciprocal, I usually do the weird like squiggly line, like nothing canceled, it just moved. But when you do multiply by the reciprocal, you're like, please, please, please let something cancel. And the 3x plus 2's do, the 13's as well. So I'm left with an x once again, which was the whole point. So look, I get that that's a lot. So if you need to, like you just wrote it, you might want to rewind and go ahead and just watch it now. You already have it. Maybe just rewind to the beginning of that part B and just watch the process. You can kind of soak it in a little bit more. All right, just throwing it out there. But that was the end of the notes. So I'm assuming the homework will be posted somewhere, and that's what you should be switching to next.